The automobile industry is on the hunt for a compact yet powerful engine. Traditional small gasoline engines often fall short, while diesel engines are typically bulky and heavy. Enter LiquidPiston, a company poised to revolutionize combustion engines and mobility. But what makes their engine so special and how does it work? Let's dive into how this tiny powerhouse is set to transform the entire auto industry. Following closely on the heels of Mazda's announcement of its all-new Wankel engine, we have another exciting development in the world of rotary engines. LiquidPiston, an innovative engineering firm backed by the US Pentagon, has introduced the XTS210 engine. This groundbreaking engine is designed for a wide range of applications. The XTS210 engine is nothing short of extraordinary. It's a 25-horsepower two-stroke supercharged liquid-cooled 210 cubic centimeter rotary engine that reimagines the traditional Wankel design. Unlike the Wankel engine, which features a triangular rotor within an oval-shaped housing, the XTS210 boasts an oval-shaped rotor inside a triangular housing. This unique configuration results in fewer moving parts, reduced friction, and a higher compression ratio, adding to its innovation. The XTS210 employs a patented thermodynamic cycle known as the high-efficiency hybrid cycle, or HC. This cycle merges the best aspects of diesel and gasoline engines, allowing the engine to operate on various fuels ranging from gasoline to diesel to jet fuel, while achieving high efficiency and low emissions. So, in late 2022, LiquidPiston actually secured a $9 million contract with the US Army to develop a prototype based on the XTS210, which is specifically designed for military use. This prototype, which is expected to be ready by 2024, will be tested on a hybrid electric vehicle platform. The Army's goal here is to replace its current diesel piston engines with something significantly smaller and lighter, up to 80% smaller. This represents a monumental leap in engine technology, similar to the transition to fuel injection. Creating an engine that maintains high power output on a larger scale required some complex engineering and innovation, and that's a challenge LiquidPiston is really well equipped to tackle. With over a decade of experience refining rotary engine technology backed by various government agencies and private investors, the company has showcased its engines across multiple platforms, including drones, generators, and motorcycles. LiquidPiston claims their engines can deliver up to 10 times more power density than conventional engines, producing more power with less weight and size. The XTS210 from LiquidPiston is set to redefine what's possible in engine technology, offering a compact, efficient, and powerful solution that could reshape the future of mobility. So, back in 2003, Dr. Nikolai Shkolnik and his son, Dr. Alexander Shkolnik, came up with a brand new thermodynamic cycle that, honestly, really had the potential to change the world of combustion engines. They called it the high-efficiency hybrid cycle, or HC for short. This cycle cleverly combined the best features of both diesel and gasoline engines, including things like a high compression ratio, constant volume combustion, and overexpansion. On top of all that, they designed an engine that could actually use this cycle, and it had a rotary configuration. They decided to name it the X engine, and they patented the design in 2004. After this breakthrough, they went ahead and founded LiquidPiston Incorporated, a company focused on developing and bringing their innovative engine technology to market. Jump ahead about 20 years, and this technology startup, which has been recognized by MIT, Popular Science, and others, is now operating out of a 12,000 square foot facility in Bloomfield, Connecticut. Here, they design and test their engines with advanced equipment and software. Most of their production happens in-house using CNC machining and assembly, and they also take care of software engineering and modeling for the engine systems. For certain parts and materials, they team up with outside partners. While LiquidPiston's patented HC design remains a crucial part of their technology, they're now exploring fuel energy conversion solutions for various hybrid power systems. This includes applications for unmanned aerial systems, mobile power generation, and auxiliary power units. These applications require compact, lightweight, efficient, and multi-fuel capable engines that meet demanding performance and environmental standards. LiquidPiston's engines are designed to meet these requirements, offering up to 10 times more power density than conventional engines. Moreover, LiquidPiston is determined to establish itself as a global leader in scalable combustion engines. It produces smooth, consistent power from an engine literally the size of a basketball thanks to its ultra-high power-to-weight ratio. This engine is especially appealing for systems where every gram matters: drones, lightweight aircraft, hybrid electric vehicles, and portable generators. These fields demand compact engines that run efficiently under load, handle rapid RPM changes, and operate reliably across a wide range of temperatures and environments. Returning to the military's interest in this sports ball-sized but, fully scalable engine architecture, the XTS-210 had to satisfy four major requirements before it could even be considered for serious deployment. First, portability and configurability. The engine can operate as a standalone combustion engine or as part of a hybrid electric system. It can rev up to 7,000 revolutions per minute, which pairs well with high-speed electric machines like generators, power inverters, and compact motors. This multi-role adaptability really increases mobility across military hardware, from unmanned aerial systems to land vehicles to small reconnaissance aircraft. With 5 times the power-to-weight and power-to-volume density of a diesel engine and up to triple the torque-to-weight ratio, it honestly redefines what a small engine can do. Second, the XTS-210 is built with military-grade toughness. It can run on compression ignition or spark ignition, depending on the fuel being used. It's compatible with JP8 and Jet A, the fuel standard across the U.S. military, but also works on gasoline, diesel, methanol, ethanol, natural gas, propane, hydrogen, and even biofuels. That means the same engine platform can be deployed globally without worrying about fuel availability. Third, the liquid cooling system allows the engine to hold optimal temperatures even at high boost levels or in extreme climates where air-cooled engines struggle. Higher temperatures usually mean lower efficiency and reduced reliability, but liquid cooling helps maintain performance in desert conditions, high-altitude missions, or heavy load situations. Building on this foundation, LiquidPiston's long-term strategy extends beyond immediate military contracts. The company is actively pursuing commercial partnerships to integrate the XTS-210 into next-generation civilian technologies. Industries such as automotive, aerospace, and portable energy are prime candidates for this disruptive engine architecture. The inherent flexibility of the design means it can be scaled up or down to meet specific power requirements, from small handheld devices to auxiliary power units for large vehicles or stationary power grids. A key advantage in the commercial sphere is the engine's multi-fuel capability. In a world increasingly focused on energy diversification and sustainability, an engine that can seamlessly transition between conventional fuels, biofuels, and even hydrogen offers significant strategic value. This future-proofs the technology against shifting fuel economies and regulatory landscapes. Furthermore, the reduced part count and simplified mechanical layout of the Rotary design promise not only manufacturing efficiencies but also the potential for lower maintenance costs and increased durability over traditional piston engines, a critical factor for commercial adoption. Finally, adaptability and scalability. LiquidPiston doesn't simply want the XTS-210 to power a few Army prototypes. Their vision is far broader. They want to position this rotary engine as the most practical, widely compatible combustion platform of the next generation. The company is exploring applications in auxiliary power units, mobile electric power stations, VTOL aircraft, drones, unmanned systems, and even hybrid electric propulsion for urban air mobility. In the near future, LiquidPiston aims to deliver an XTS-210 prototype to the U.S. Army, likely around 2024. Although they've built multiple Rotary X-engine variants for defense applications before, this supercharged basketball-sized version is the most refined, efficient, and promising of the entire lineup. Ultimately, LiquidPiston hopes the XTS-210 will spark a renaissance in compact rotary engines. They envision it as a real alternative to piston engines, not just for military systems, but for electric cars, drones, aircraft, generators, and portable power solutions across commercial industries. Their plan also includes licensing the design to manufacturers who want to integrate this technology into their own platform.